Now, in today's lecture, I will talk about some very important theorems relating to moment of inertia, and these theorems are theorems for perpendicular and parallel axis. So first of all, I will talk about the theorem of perpendicular axis, and then later I will discuss the theorem of parallel axis. So let us have a look at its statement. This theorem states that moment of inertia of a plane lamina about an axis perpendicular to plane of lamina is equal to sum of moments of inertia of the lamina about the axis at right angle to each other. So how? Let us have a look at it. Say there are different axes. This x-axis, it's y-axis, and it's z-axis. And say this is the plane lamina, and it's placed in xy plane. This is the plane lamina, and it is placed in xy plane. Now, according to this theorem, the moment of inertia about z-axis is equal to ix plus iy. Right, this is our purpose which we want to prove that. And here both x and y are perpendicular to each other, means x is perpendicular to y and x is perpendicular to z, and similarly y is perpendicular to z. Now, if object, say there is some point represented by ri is its position vector, and say it is at distance yi from x-axis and at a distance at means this is a p point, ith point, and its mass is mi. Now, moment of inertia about x-axis, let me denote it by ix. So if it starts rotating about x-axis, so that means the distance of ith point from x-axis is yi. That means ixi can be written as miyi square, its summation. And similarly, moment of inertia about y-axis can be written as iy, and the perpendicular distance of this, if it starts rotating about y-axis, so that means the perpendicular distance from y-axis is xi, so it is mixi square. Now I am interested to find out iz, and it starts rotating, and iz is nothing but the distance of z-axis from ith point is ri, so it is mi ri square, its summation. But if I try to look at this diagram, So from this diagram, I can say that Ri square is equal to xi square plus yi square. So if I put their values, mi xi square plus yi square summation. So this, after simplification, this leads to iz is equal to mi xi square plus mi yi square, and let me call this is as pi iy and this is ix using two results here. So therefore iz is equal to ix plus iy. So it is the theorem of perpendicular axis, and hence the result has been proven. Now I will talk about theorem of parallel axis. So this theorem states that moment of inertia of a body about any axis is equal to the sum of its moment of inertia about a parallel axis through its center of gravity and product of its mass and square of the distance between the two axes, right? So let us try to look at it mathematically. Say this is one axis about which body is rotating, and say this is the body, and say it is its center of mass passing through AB, which is its center of mass, and say there is some point P and it is at a distance xi from the center of mass and mi be its mass, and say h is the distance of this center of gravity from this parallel axis. So this distance h plus xi is the distance of this observation point from here. So let us try to understand this here. So let CD be the axis about which we are interested to find the moment of inertia, and let AB be the axis parallel to CD axis, and this axis is passing through center of mass of the body G, because it is the center of mass which I am choosing. So now moment of inertia about CD of ith point. So it can be written as summation mi xi plus h whole square, and this is equal to mi xi square plus h square plus 2hxi. Its summation, it can be written as mi xi square, its summation mi h square plus 2 mi xi h, its summation, right? So it is mi xi square. Xi is the distance from the center of gravity. So it is the moment of inertia about center of gravity plus mh square, because summation mi is the total mass of the body, h square can be taken outside, plus 2hmixi. Since xi is the distance from the center of gravity, so keeping this in mind, this term will be vanishes zero, because some points are lying somewhere here and another points are here, and overall their sum will be equal to zero about the center of gravity line. So therefore, if it will become zero, so that means moment of inertia about parallel axis, it's Ig plus mh square, and this is the required result, right? So that's all for this lecture.